Last episode, you tokenized one sentence by hand, fed I love this into the tokenizer, and watched it come back as input IDs and an attention mask. Satisfying, but one sentence is a demo, not a training set. To actually fine tune a model, you need thousands of examples, and you need every one of them tokenized the exact same way. The good news, you do not write that loop. The datasets library loads the data for you, and one function, map, runs that same tokenizer across all 50,000 rows. Today, we load a real dataset from the hub, tokenize the whole thing in one call, and learn to read the train data splits that fine-tuning depends on. Up to now, you have been bringing your own text, a string you typed into the script. But real machine learning runs on datasets that other people already cleaned, labeled, and published. The Hugging Face Hub hosts tens of thousands of them, from movie reviews to medical notes to code. Instead of hunting down CSV files and parsing them yourself, you name a dataset and it arrives ready to use. The dataset we are loading is IMDb. 50,000 movie reviews, each one labeled positive or negative. It is the hello world of text classification. Big enough to be real, small enough to train fast, and perfectly balanced. 25,000 reviews to learn from, 25,000 held back to test on. Every review is just two things: the text of the review and a label that is 0 for negative or 1 for positive. That train test split is not a detail, it is the whole point of honest evaluation. You train the model on the train split, and you never let it see the test split until the very end. Why? Because a model that has seen the answers can memorize instead of learning. The test split is the sealed exam. It tells you whether the model actually generalizes or just remembered. Datasets hands you both splits clearly separated, so you never mix them up by accident. When the data arrives, it comes wrapped in a dataset ticked. Think of it as a labeled drawer for each split. One drawer marked train, one marked test, and inside each drawer the same shape of data. You can ask any drawer how many rows it holds, what columns it has, or hand you a single example to look at. It is just a dictionary, but a dictionary that knows it is holding tabular data. Now the key move. You have a tokenizer, the same auto tokenizer from last episode, and you need to apply it to every single row. The naive way is a for loop over 50,000 reviews. The datasets way is map. You write a tiny function that tokenizes one batch, hand it to map, and it sweeps across the entire dataset for you. Same tokenizer, same settings, every row treated identically. And map does not replace your data, it grows it. Before the call, each row has text and label. After the call, those are still there, and two new columns sit beside them: input IDs, the token numbers the model reads, and attention mask, the 1-0 pattern that marks real tokens from padding. The reviews are now in the exact numeric form a transformer expects, and crucially both splits got the identical treatment. One more habit worth forming early: map with batched true is dramatically faster than one row at a time because the tokenizer processes a whole chunk in a single call. On 50,000 reviews, that is the difference between seconds and minutes. The pattern is always the same. Define a tokenize function, map it batched across every split, and you have a fully tokenized dataset ready to train. Let me show you the file. It is one short script, zo4 datasets.py, and it fits comfortably on a single page, about 20 lines. 4 moves: load the dataset, peek at its structure, define a tokenize function, then map it across both splits and confirm the new columns landed. First we load. From datasets import load dataset, then raw load dataset IMDb. That single call reaches the hub, downloads the dataset the first time, caches it locally, and hands back a dataset dict. We print it, and right away you see the shape, a train split with 25,000 rows and a test split with 25,000 rows, each carrying the column's text and label. Next, we look before we leap. We grab one example with raw train and print its keys and the first 100 characters of its review text just to prove the data is what we think it is. A real review string and an integer label. This peak step is a good reflex. Never tokenize a dataset you have not actually eyeballed first. Now the tokenizer. We load auto tokenizer from pre-trained on a small BERT checkpoint, Distilbert base uncased. Exactly the same kind of tokenizer you used by hand last episode. Then we define tokenize, a 4-line function that takes a batch, runs the tokenizer on batch text with truncation on, and returns the result. That function is the unit of work map we'll repeat. And here is the payoff line. Tokenized DAOs raw.map, tokenize batched true. One call, both splits, every row tokenized. We print tokenized to see the columns grew, and we print the column names of the train split to confirm input IDs and attention mask now sit right next to the original text and label. The data is ready and tokenized, and next episode we hand exactly this tokenized dataset to the trainer and actually fine-tune a model on it.